The James Webb Telescope has just announced the clearest image of Proxima B in history, revealing astonishing details about this potentially habitable exoplanet. Join us as we embark on a journey through space to uncover the mysteries of Proxima B and discover whether it could be the next Earth. Let's take off on an exciting exoplanet adventure. In the vast expanse of space, a mysterious planet exists in the habitable zone of its star Proxima Centauri. This planet is not just any ordinary rock. It's the Earth's cousin, Proxima Centauri b, located a mere 4.2 light-years away from us. This planet is shrouded in mystery and wonder. Could it be another Earth, with oceans and life teeming on its surface? But wait, there's more. Proxima Centauri b is not alone in its journey around the red dwarf star. It has a fellow traveler, the super-Earth, Proxima Centauri c. Who knows what other secrets this star system holds? Perhaps another companion is waiting to be discovered. The mysteries don't stop there. Proxima Centauri b receives just about the same amount of energy from its star as our Earth does from the Sun. Could this mean there's water on its surface, perhaps even life? As we venture beyond our own solar system, we discover a whole new world of exoplanets, planets that orbit stars other than the Sun. With 206 trillion stars in the universe, the possibilities of exoplanets are endless. Some exoplanets even roam free, untethered to any star, like rogue travelers in space. Among them all, Proxima Centauri b stands out as a truly remarkable and enigmatic planet. With a year that lasts just 11.2 Earth days and a distance from its star that is 20 times closer than Earth is to the Sun, it is likely that one side of the planet is always bathed in daylight while the other remains in perpetual darkness. Let's talk about Proxima Centauri b, the star that orbits the red dwarf Proxima Centauri and forms part of the Alpha Centauri triple star system. This system consists of Rigil Kentaurus, or Centauri A, Ptolemy, or Centauri B, and Proxima Centauri, or Centauri C, creating the nearest star system to our solar system. The two stars, Rigil Kentaurus and Ptolemy, form the binary known as Alpha Centauri A and B. These G and K-type stars appear as one in the constellation of Centaurus and are the third brightest stars in our night sky with a peak amplitude of -0.27. Now, let's focus on Proxima Centauri, also known as Alpha Centauri c. This red dwarf or M-type star is located 0.21 light-years away from the other two stars, approximately 13,000 times the distance between Earth and the Sun. Interestingly, it is technically the closest star to us. In fact, the name Proxima Centauri translates to the nearest star of Centaurus in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn Eaton Innes. Despite being our nearest stellar neighbor, we can't view it with the naked eye as it has an apparent magnitude of 11.13, far greater than the maximum human eye limit of 6.5. But don't let that fool you. Proxima Centauri is still a star worth marveling at. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. They may not generate much energy, but the internal convection process at their core keeps them glowing for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still being debated. One major concern is that it's a flare star, meaning it experiences frequent and unpredictable energy fluctuations. The habitable zone of a red dwarf is also much closer to the star compared to a G-type star like our Sun, projected to be between 0.023 and 0.054 Australian dollars. But Proxima B is not as habitable as it seems. Though it's the same distance from its star as we are from the Sun, there's more to the story. Proxima B is bombarded by extreme ultraviolet radiation from its star, hundreds of times stronger than what we receive from our Sun. The intense radiation destroys even the lightest molecules of hydrogen, not to mention nitrogen and oxygen. Moreover, even if a planet is at the right distance from its star, it doesn't necessarily mean it can support life. Proxima B might not have a suitable atmosphere, which is essential for regulating climate and supporting a water-friendly surface. Without it, any living organisms would be vulnerable to dangerous space weather, making life nearly impossible. While Proxima B may look like Earth on the surface, it's far from being able to support life. Despite the challenges, some people still have hope. One instrument that has captured the attention of astronomers is the James Webb Telescope. After numerous delays, it was finally launched in 2018, and it will help determine whether or not there is life on Proxima B. However, as with all things in science, the search for answers is rarely straightforward. Many modifications were required to ensure the James Webb Telescope would produce accurate images. As Avi Loeb, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also re-emit it as infrared light. The James Webb Telescope is specifically designed to observe infrared light, and it can take photos of this light on the planet's surface to look for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that isn't conducive to life? As Ed Turner, an astrophysicist at Princeton University, warns, the presence of an atmosphere doesn't guarantee life. Proxima B could be like Venus, with a thick atmosphere that's 90 times denser than Earth's and extreme heat that would make life impossible. The quest to unravel the mysteries of Proxima B isn't without its challenges. Although the James Webb Telescope holds promise, astronomers are pressed to find a way to observe planets like Proxima B, with costs mounting. The risks are great, but the rewards are even greater. The chance to glimpse into the unknown and uncover the secrets of a distant planet that might hold the promise of life is one astronomers are willing to take. Let's say hypothetically that Proxima B is hospitable. Could we even go there? As the closest exoplanet to us, it's almost like looking into our cosmic backyard. It's roughly the same size as Earth, and its location in the habitable zone suggests it could have the conditions for life as we know it. Proxima B's proximity makes it a prime target for interstellar missions, but the reality of traveling there is another story. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. However, a proposed solution is solar sails, ultra-thin sails that could be used to accelerate a spacecraft to the Alpha Centauri system. This technology uses solar pressure to keep the spacecraft on course, with expected speeds 10 to 20% faster than the speed of light, potentially reducing the journey to just 20 years. The discovery of Proxima B has reignited humanity's fascination with space exploration, giving us hope that we may not be alone in the universe. The James Webb Telescope, a marvel of modern technology, has the power to take us back to the very beginning of the universe, 13.7 billion years ago. The farther away an object is, the longer it takes for light to travel from it to us. This means the James Webb Telescope can see objects farther away than any telescope before it. It can observe these objects in longer wavelengths of infrared light, allowing us to see even more distant stars with greater clarity than before. As with any advanced technology, the James Webb Telescope does have its limitations. For instance, detecting an atmosphere doesn't necessarily guarantee life. Proxima B could be like Venus with a thick, hot atmosphere that's not suitable for life. But if Proxima B does have an intelligent civilization, they may use orbital mirrors to reflect sunlight from the day side to the night side of the planet. How cool is that? There are countless exoplanets waiting to be discovered in our universe. Some are massive gas giants, while others resemble Earth. Among these are gas giants like Jupiter and Saturn, with some dubbed superjupiters. There are also hot Jupiters, which orbit close to their stars in extremely fiery conditions. On the other hand, there are Neptunian exoplanets, similar in size to Uranus and Neptune, some of which are classified as mini-Neptunes. Additionally, terrestrial exoplanets resemble our planet, ranging in size from smaller to twice the radius of Earth. One of the most intriguing exoplanets in recent years is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth with an approximate mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b is not alone. It has a partner in crime, Proxima Centauri c, which is even further away from the star. This planet has an orbital period of approximately 5.5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more fascinating about Proxima c is that it appears to be a very bright world, possibly due to the presence of a ring system. And there's still more to discover in the Proxima Centauri system. In 2019, astronomers detected a change in the star's radial velocity, which could be the result of another planetary partner. If confirmed, this planet will be known as Proxima Centauri d and will be roughly the size of Mercury or Mars. Imagine a world where the night sky is filled not just with stars but with countless other planets, each with its unique composition and orbit. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made all the time, it's an exciting time to be an astronomer. While we don't yet have an accurate count of exoplanets, we do know that they exist, just like we know the stars that light up the cosmos. However, exoplanets are not easily observable, and it requires state-of-the-art technology and powerful telescopes to detect them. These planets are often obscured by the glare of their host stars, making them difficult to study. But with advancements in technology, direct imaging of exoplanets is now possible with some of the world's largest telescopes. To be directly imaged, an exoplanet must be large enough to be seen by the telescope, far enough from its host star not to be obscured by its glare, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can be directly imaged, but they provide a fascinating glimpse into the characteristics and composition of these distant worlds. Exoplanets are most commonly discovered through the changes they cause in their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided invaluable information about exoplanets, including their size, distance, and temperature. Here are some fun facts. Did you know that over 22% of stars like the Sun have Earth-sized planets in their habitable zones? Or that the TRAPPIST-1 system is home to 7 rocky exoplanets with water on their surfaces? Exoplanets, like the planets in our solar system, can also have natural satellites known as exomoons. With over 4,000 exoplanets discovered so far, we know that they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to discover, but there are countless other exoplanets waiting to be found. A new perspective on the universe. NASA's James Webb Space Telescope is unlocking the secrets of the universe, one discovery at a time. This remarkable telescope has been gathering information and capturing stunning images of the cosmos, unveiling previously unknown wonders of the universe. Recently, it made history with a groundbreaking discovery that will change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has discovered the first conclusive proof of carbon dioxide in the atmosphere of a planet outside of our solar system. This discovery provides critical information about the planet's composition and evolution, offering us a glimpse into the mysteries of the universe. This gas giant planet orbits a sun-like star 700 light-years away, and this finding is a significant breakthrough in our search for extraterrestrial life. NASA Administrator Bill Nelson promised that this discovery would give us a new perspective on the universe, sparking excitement among astronomers and researchers around the world. But that's not all. The James Webb Space Telescope has been busy capturing breathtaking images and gathering information about the cosmos. The stunning photos of stars, galaxies, and dust clouds spinning and colliding with each other are nothing short of awe-inspiring, and the discoveries keep coming. An international team of astronomers used the telescope to compile a detailed inventory of the innermost, coldest ice ever noted in a molecular cloud. They identified frozen versions of various molecules, including carbonyl sulfide, ammonia, and methane, as well as relatively simple complex organic molecules like methanol and simple ices like water. This comprehensive inventory provides invaluable information about the creation of future generations of planets and stars. One of the telescope's images, captured by its near-infrared camera, showcased the chameleon-eyed dark molecular cloud, which is 630 light-years away. In the infrared, the light from a young outflowing protostar SED 110 IRS-4 illuminates the chilly, wispy cloud material, and the orange dots behind the cloud reveal the light from distant stars absorbed by the ice in the cloud. This magnificent research was part of Webb's Ice Age project, which aims to study the evolution of ice from its creation to the formation of icy comets. And that's not all. The James Webb Space Telescope replicated the inner workings of a dusty disk surrounding a nearby red dwarf star, imaging it for the first time at these light wavelengths in the infrared. This discovery provides crucial insights into the formation of planetary systems and could help us understand how our own solar system was created. With each new discovery, the James Webb Space Telescope reveals more secrets of the universe, and we can't wait to see what other discoveries lie ahead. The possibilities are endless, and the mysteries of the cosmos are waiting to be unlocked. What do you think? Let us know in the comments, and we'll see you next time.